Right, here's a question on projectiles from June 2010, question number 7, Edx M2. So have a good, careful read of the question and continue playing when you're ready. Right. Now this projectiles question is slightly different from some of them, from the norm, shall we say. It starts off by giving you some information about the greatest height reached. And it tells you that the greatest height above the point of projection is 12 meters. It doesn't tell you the angle of projection, it just tells you the speed is 40. The question mentions the point O on the ground, suggesting that's supposed to be the origin, but it doesn't tell us to take that as the origin. I'm going to write down the equations for this projectile, the standard equations that you should be familiar with, and perhaps you'd like to pause the video and complete them. So for this video, for this projectiles question, we start off with u equals 40 cos theta, 40 sine theta. We're going to need these equations for parts B and C. The general velocity is 40 cos theta in the x direction because there's no acceleration, and in the y direction 40 sine theta minus 9.8 t. See if you can write down the equations for x and y. I tend to write them in the form of a position vector. If you want to write them down as x equals and y equals, go ahead. We're not wasting time here because you're going to need them for, as I said, for everything apart from part A. Because with part A there's a shortcut. So x is 40 cos theta t, y is 40 sine theta t minus 4.9 t squared. So behind that lie the Suvat equations. V equals u plus at and s equals ut plus half at squared. Right, let's do part A. Find the value of theta by making use of the fact that the height is 12 meters, the greatest height. On the next page then, what we can use is that vertically v equals 0 at s equals 12 with an acceleration of minus 9.8. In other words, looking at the vertical motion, we know that once it's gone a height of 12 meters vertically, it comes to instantaneous rest, vertically at least. The velocity is purely horizontal at the point Q. So importantly then, the initial velocity vertically for this is 40 sine theta, the vertical component. So the equation we're going to use, you might like to stop and think for a moment. The equation we're going to use is v squared equals u squared plus 2as, but applying that vertically. And that will give us 0 equals 40 sine theta all squared, that's your u squared, minus 2 times 9.8 times 12. Now a little bit of rearranging of that gives you 40 sine theta equal to 15.34, and that will give you, once you've found sine theta and then theta, it gives you theta equals 22.5. So 3 marks for that, and it's important to remember that you've got that equation v squared equals u squared plus 2as to link the initial velocity vertically with the greatest height vertically. Okay, let's go on with parts B and C. I've got them on the next page. Oh no, I haven't. I've gone too far. That's it. So now we want to find the distance OR, which is the distance travelled horizontally when it hits the ground after being thrown off a cliff. Now the equations of motion that we wrote down earlier on the first page are going to be needed. To save you going back and looking, I'll write down the relevant equation. The point is that we know at R, we know the y value. So the y value at R is minus 36 relative to that point. P is the origin. So y is minus 36. Now the y equation was 40 sine theta t minus 4.9 t squared. So we put that equal to minus 36, and we plug in the 40 sine theta from part A, and that means we get this equation: 4.9 t squared minus 15.34 t minus 36 equals 0. Solving that using the formula, or if you're lucky enough to have it on your calculator, using the relevant button, or the relevant mode, I should say, we get t equals 4.7 seconds. That's the only positive value of t. That gives us the time. That's not what they're asking. They want the distance OR. So now we've got to use the x equation. X equals 40 cos theta t. So when you plug in the value of theta of 22.5, it was from the first part, 40 cos 22.5 times 4.7, we get an x value of 173 meters. And that's part B. That was 6 marks for finding the distance OR. And for the last part, for the speed, there's two alternatives here. There's one slightly shorter way. You could find the velocity vector by working out 40 cos theta t and 40 sine, the two components of velocity. But slightly quicker than that, since we're going to have to find the, by that method, we'd have to find the magnitude of v squared anyway. To find the speed of the ball as it hits R, let's use energy, conservation of energy. We're assuming there's no air resistance in this question, so we've got the loss of gravitational potential energy to consider, and we've got initial kinetic energy also to consider. So the energy equation is saying that the GPE plus the KE is a constant. We'll have, it'll take this form, and then we'll put the numbers in. A half mu squared plus the gravitational potential energy at the start will equal half mv squared when it hits the ground. Putting the numbers in there then, 1/2 m 40 squared plus m g 36, that's right, h, equals 1/2 m v squared at the ground. That gives us v squared equals 40 squared plus 72 times g and gives us v equals 48 meters per second. Yeah, just filling that in for you. That's 2305.6. And v is 48. And that's the end of the question for the final 3 marks. So, going back, for the first part of the question, to finding the value of theta, just 3 marks, 1 method mark, 2 accuracy marks. So the method mark was for applying v squared equals u squared plus 2as, and the accuracy marks were for putting the correct expressions in the equation here and finding the correct value of theta. That's the 3 marks for part A. For part B, for the 6 marks for finding the 173 meters, we had, right, for working out the time for this first part down to the time is 4.7 here, one method mark, 3 accuracy marks. So for using y equals minus 36 and putting it in the correct equation for y, a method mark, and 2 accuracy marks for setting up the right equation with the right terms in it. Remember, you've got to substitute the sine theta from the first part, and for finding the t, another accuracy mark. And then a method and an accuracy mark for getting the correct value of x to 173 meters. That's your 6 marks for part B, and for the very last part, for the 3 marks, you had a method mark for using energy, or alternatively you could have found the 2 velocity components and then gone from there. A method mark for that, and then 2 accuracy marks. So an accuracy mark for putting in the correct terms in the energy equation, and an accuracy mark for finding the final answer. And that's it. That's question 7 from June 2010.